Hello. My name is Irina, and I'm working at TypeFox, where together with my colleagues we develop domain-specific languages for our customers. And today I will tell how to design a domain-specific language that perfectly solves your problem. So, what's waiting for you during this talk? We are speaking about domain-specific languages in general. It's our first chapter. And the second chapter, I will share TypeFox experience that we gained over the last 7 years. So, yeah. The first thing that we need to discuss when we're speaking about DSL is, of course, definition. So, DSL is a language specialized for solving problems of a certain class. So, of course, you met many such things in your life. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, many of these things, all of them are domain-specific languages. So, like NTLR for lecture and parser definition, or SQL for managing data held in a relational database. So, and then we need to speak about domain-specific languages advantages. So, since it's domain-specific, main characteristic of it is that it's specialization on a concrete domain. So, and it gives us many benefits, like faster development, because our language, our domain-specific language, has better expressiveness. It can be used and shown to non-programmers because it uses domain vocabulary and looks like much simpler than general purpose languages that we usually use, like programmers. So it also can provide validation at the domain level because we have this extra information about the domain. And besides, we also can lower maintenance cost. So, and about some of these advantages, we are speaking separately from the slide. The first thing is lower maintenance cost. So here you see two cases when you have development with general purpose language and with domain-specific language, and you can see difference. So concretely, you see this feedback loop that you have to all the time support when you develop your application in GPL, so you all the time have to share information and knowledge between domain experts and developers. Developers share some developers information, domain experts some domain information. And it's of course costs pretty much. And when you use domain-specific language, you're able to split this such way that domain experts can concentrate on development only using their knowledge, and developers using only their knowledge. So this way exactly happens is lower maintenance cost. Another thing is, another advantage that we mentioned is good for non-programmers. Here I just wanted that you would see this wonderful code snippet. Here's very many keywords or things that usually you'd never meet in general purpose language, but you see it in domain-specific language because we are able to use domain vocabulary, so like material, batch, product, and so on. So, now we came to the most interesting and the most important thing during this presentation. So it's DSL classification. Here the first thing how you can classify your DSLs is by relation to host language. So it can be internal and external. By paradigm, it can be structural and behavioral, and by execution, it can be interpreted and transpiled. By representation, it can be textual and graphical. So we will not speak about textual and graphical, I think it's clear, but we will speak about other classifications. So the first thing is about relation to host language. Here we have internal and external. And internal, it's such languages that don't add new syntax, and as a result, you don't need to write a parser for this extra constructs that you use, because implementation of such DSL looks like just creating a separate library in some host language, and then you can reuse this host language features, everything, and for development and for parsing and whatever. So examples of it, for example, Gradle Kotlin DSL. If you used Gradle with Kotlin, it's actually not not real DSL, but it's something that's written in Kotlin. It's normal Kotlin. Or maybe you're familiar with a bunch of DSLs in Lisp. How you can make your internal DSLs using Lisp by passing some name of your function, like first element of your list. So, and about external is, these languages add new syntax, and you have to implement everything. So you have to implement parser, or language support, and IDE support, and that's usual languages that we will speak today, and that usual languages that you use, like general purpose languages. So, next classification is by paradigm. So I just wait 3 seconds, and I think it's clear. So 1, 2, 3, and we can switch. So next classification by execution. It can be interpreted, yay, and code generated, so or transpiled. Yeah. So in case of interpretation, we traverse our AST and do operations based on node's content. In this case, semantic of your language is implemented right here. Yeah, and in case of transpilation, we transform the ST to another language. And in this case, semantic of your language goes to outsource to this, this another language. So, yeah. Now, one of the most interesting things, I hope that you came because of this. So it's TypeFox experience, and the first thing that we do, we come back again to classification. So yeah, because we have our custom classification, it's by problem solution. So based on all, almost all DSLs that we developed during this time, we can split these DSLs by how exactly the problem was solved. So it can be like code simplification. It's for the cases when you have to write very complicated, very boilerplate code all the time in your GPL. Maybe that contains some complicated data like binary addresses, and making DSL from it, you can generate all this code, and that's how you get simplification. So next thing is data model description. So then when you need to describe your data and then generate some code out of it. So it's also the case. Interoperability. That's when you want to share data of your DSL and some other language, maybe even GPL. The last thing is language extension, when you literally want to extend existing language with some new functionality. So I have no more slides about this to explain this, but I have concrete examples for you. So real examples from our project that's happening right now. So, and the first thing called component definition language provided by a dynamic products company. So that's a company that provides low-cost solutions and also give opportunity to generate smart forms from exactly this component definition language. And these smart forms are so smart that you are able to describe behavior of your forms and generate forms. And then now we can come to the language. So, component definition language. This language describes business entities and their representations. That's core characteristics. So now, we will take a look further about it, and we take a look at the domain of this language. So it's about business processes automation. We take a look at the problem. So the problem that arises here is that business processes data model must be re-implemented for different areas and different use cases, like web forms and database schemas, and we can provide a solution for that. So in particular, we can provide some one-time customization of the data model, and translate it into required representation. And that's exactly what we will do with our domain-specific language. And that's how this language looks like. So here now will be some text. Don't read it, please. If you will want to read it more, you can take a look maybe at the video. But now we take a look at content. And that's how this language looks like. It has entities that looks like components. It has input and output fields to express public setters and read-only fields. It has annotations to say the code generator how to represent the component, and it has some special syntax to describe effects and behavior of all this. So because we describe not only data model but also the behavior. This language has VS Code support. And finally we should discuss classification, so how we can relate this language. So you can, play with me and do with some tests. Guess earlier than I can. Open the answer. So it's external DSL. It's structural and behavioral. So it's one of the moments when the language combines both. Paradigms in this case. So it transpiled in TypeScript. By representation is textual, and problem solution is data model description. So we describe our data model and then make further code generation. So now we can come to the next language. The next language is a DSL by a Silicon Valley-based health tech company. This DSL generates SQL code to sample the data and determine if the case is insurable. So it's for insurance companies. So how that's working? By default, the insurance company has to pay money for each insurance case. But sometimes it's not the case, and they want to check, do they have to pay money or not, and how much, and all the things. And for that, it's necessary to write some request to database, to the SQL database. And that's the main problem. And as a result, we have a problem that we have to write long SQL queries with a lot of boilerplate code, and the user must know SQL. It's also a problem because we want to get opportunity to non-programmers also describe our conditions for refunding money. And solutions that we provide here is simple code constructs that will translate to SQL queries automatically. So that's how this language looks like. So that's the simplest thing, minimal entity. It's if, each entity is if. It has no else branch, but has only then branch. So if condition is true, it means that we don't have to pay money, but have to do something else. Pay less money or don't pay money at all. And that's what will be described by this function in then branch. So condition is a set of clauses connected with and or. And a claim is a comparison, a check in ranges, and a functional call. So in such a way, we can translate SQL code and get the answer. That's language has integration and playground in the web portal. And here we can start to execute this language and then get a SQL query and results from database response. I find it very interesting. So now we have to speak about the classification again. So it's external DSL again. It's behavioral. It's transpiled to SQL. It's textual, and solution is simplification. Next company is, next language is BBJ by Basis International. It's a company that provides business solutions, and language by itself extends BASIC with Java to modernize business solutions. So domain is worldwide. It really literally can be used everywhere, and for example, it can be banking, automotive industry, and hotels, and everywhere. And the problems that we want to solve is preserve proven business solutions while adding the innovations of Java. So people who are working in this area, in this domain, very strive to reliability. So they can't just switch to different things and have to use very reliable solutions. But at the same time, they strive to use some innovations, and that's how we come to this problem. Solution can be adding new syntax on top of business basic language to call Java libraries. So, and that's how this language looks like. So we added syntax for class definition. And also we can use hash set from Java here and there. So this language has support in Eclipse IDE and in VS Code. And again, classification 1, 2, 3, 4, 5. By problem solution, it's interoperability, because now we can communicate Java and basic, business basic, and it also extends the language. One more example. That's Nuant DSL by Nuant. So, and here we step on blockchain area. Yay. Nuance generates SQL code to select and analyze blockchain information. So blockchain releases some events, and they're recorded in some database, and we want to analyze them. And for that, again, I forgot to make the main. For that, we need again to go on the database and write some SQL queries. And besides, in this case, user must know SQL and DB structure to write these queries. And solutions that can be provided here is simple code constructs that will translate to SQL queries automatically. Besides, this language also provides some capabilities for some analyzing. So, and here we take a look again on this code snippet. So each entity is chain of function calls, and arguments of a function depends on the arguments of a previous function in the chain. Yeah, I hope you understood this phrase now. So, what it means that you can see here that argument this Uniswap v3, and another case it's Uniswap v2, and these arguments influence on what you can pass as arguments to the next function. Yeah. Okay. Besides, you can store the SQL response in a variable to display and analyze it. You can display it in different ways, by the way. And finally, we have integration with Python. So some information can be transferred between Python and Nuance, such way that you can, for example, make further analyzing of information that you got using Nuance. So. This language has support in notebook and VS Code, and again, here is our favorite classification. So 1, 2, 3, 4, 5. In some moment, I have to count in reverse order. One more case is language DSL by TypeFox. So I couldn't not tell about it because it's actually an interesting case, but I have not enough time, so I just do this. So it's a language which generates a parser and a semantic ST model to provide language support, and then 1, 2, 3. Yeah, that's the language. And here which constructions you have. So it's actually EBNF like grammar. Yeah. And here you have support in VS Code and in background on the web page. So that's we decrease a bit speed. Oh, okay, decrease a bit content. So now what this language exactly does? By classification, it's external, it's structural and behavioral, because we describe and structure of our DSL with the grammar and behavior. It's transpiled to TypeScript, obviously, it's textual, and it's holds data model description, the problem solution. One more thing that I have to mention is graphical DSLs. So we kind of finished now with examples about textual DSLs and speak about graphical. So it's one real project and very short summary. So its domain is railway. It's for safety critical systems, and it's basically a textual DSL from which we generate graphical representation. That's another very important slide. So here, if you want to take a picture, that's the slide that you need to keep. Here is a summary of all the languages that we considered now, and their classification. So I find it wonderful. So it's kind of, culmination of work about collection information about domain-specific languages that we developed in TypeFox. So things that you can see here is that we don't develop internal languages. Not because it's bad, but because it's just not that need for our customers. So by our experience, we develop only external DSLs. Mostly they are textual, and also no fully structural DSLs. For our experience, it's mostly or behavioral or combined. Okay, so the next thing is finally how to design a DSL. That's concrete guide for what you should do. So the first thing, you should define your domain and the problem. The second thing, you should classify the DSL for all these classifications that we discussed in this order that I put, because yeah, it's really helpful. The third thing that you have to understand which solution fits the best. The second thing, that what's the preferable paradigm that you need to use. Then you should think, do you need graphical representation, and then how should it be executed, and finally, how should it be implemented? Again, interpreted or transpiled. And finally, when you answer these questions, it has to help you to design your syntax based on the answers. So, for example, answering the question about paradigms, you can already understand you need more functional language or more imperative language. You understand a bit better which keywords you want to use. So, classification is very helpful. The only one very strict advice that I can give here is that you have to be specific. Don't duplicate JSON and don't replicate your favorite programming language. So if you understood that you reinvent some GPL, maybe you don't need to use the DSL here for solving this problem. Okay. So we spoke how to design DSL, now we need to speak how to implement it. So you need to support some language features, just again, 1, 2, 3, 4, 5, 6, 7, so many things. And for IDE features, you have to implement also many things. And for that, you can use different language workbenches. So, and since I'm working in TypeFox and we develop Langium, so I tell some short recall about Langium. So that's a talk from previous year. If you want to know a bit more about Langium, you can scan QR code and watch it. Final recall of this presentation is classification. It's full classifications that we discussed. That's the most important what you need when you think about designing of your DSL. And now we're in the end of the presentation. It was fast overview of all our experience. And here's the reversed QA. I hope that after this presentation you can answer these questions. That's actually questions that I usually get when I tell that I'm working on DSL development. And I really hope that you can answer those questions after this presentation. Thank you for your attention.
I saw a couple of people pulling their cell phones out when you're saying you can scan this QR code and you press next. Bring them back.
Yeah, please.
For all those with benefit of
So the talk is a general review about Langium, and it's a nice point to start, to get familiar with it, and then you can read our wonderful documentation on our website and make user experiments, and of course, join to our dev meetings every Wednesday at 4 by set. Some questions? If no questions, I will think that I explained everything very perfectly.
I have a question, but it's not on what you said, it's on what is coming next. So, we hired TypeFox, we have the best DSL, it's perfect, the perfectest DSL.
Yeah, exactly.
And then the new domain expert comes in and makes mistakes. What kind of debugging tools do you offer that are available on DSLs? Because JavaScript has a really cool debugger, and they're not going to go to the transpiled level. What kind of debugging can happen at the DSL level or troubleshooting?
Okay, then here I can answer that we are working on it.
That's one question we're talking about that.
Yeah, exactly.
What time? Please not learn that.
3:30, I think.
Just the last session before the closing session. 3:30.
Yeah.
3:30.
Excellent. I'll see you there.
So continuation, please join the talk of Christian. More questions? Okay, then I will think that you can now perfectly design your DSL. And come to us to implement maybe, we will help. Thank you.